In this problem, we are going to use a composition of functions to determine whether or not these two functions are inverses of each other. So first I'm going to work f of g of x. So I'll replace the g of x with the actual expression that is the g of x plus 9 over 7. So I will now use the actual f function and put in the x plus 9 over 7 in the function. Now let's evaluate by first distributing. And now we're going to find a common denominator, which is 7. And that would be a minus 49. And it's all over 7. And our last thing we can do is combine like terms, and we get 9x plus 32 over 7. Clearly we didn't get just x, because if functions are inverses, I should be able to take one and compose with the other and just have x. And obviously I got something different. You can confirm that it doesn't work the other direction by working g of f of x. So we're going to perform g on 9x minus 7, and that would be 9x minus 7 plus the 9 that's already there, all over 7. And our last little step will be to combine the constants, 9x plus 2, all over 7. Again, I didn't get x. So these are not inverses of each other. So just to explore one step further, let's look at f of x equal 9x minus 7. The last thing you do in this function to x is to subtract 7. So clearly any inverse is going to have to add 7. The first thing you do to it is multiply by 9. So the last thing I want to do to it is divide by 9. So 9x minus 7 would have an inverse that's x plus 7 divided by 9. I'm going to mark it with the inverse symbol. So you can kind of look at what it's doing. First it multiplies by 9, then it subtracts 7. I want to, in my inverse, do it in the opposite order and the opposite operation. So since I do subtract 7 last, I want to do add 7 first. Since I do multiply by 9 first, I want to divide by 9 last. And you can see that if I compose f with g of x, I'm going to get f evaluated at x plus 7 over 9. Now I'm treating the f inverse as if it were g of x. Okay, I should have written f inverse there. But that is 9 times x plus 7 over 9. And minus 7. Okay, now in the first term here we're multiplying by 9, so these are going to cancel, leaving me x plus 7 minus 7. These guys eliminate each other, leaves me just x. Now that's what inverse functions are supposed to do. So I could try it again on the, it has to work both ways. So I'm going to try g of f of x. So that's g performed on 9x minus 7, which is 9x minus 7 plus 7 all over 9. Now what did I do? I took the 9x minus 7 right here and I replaced the x with it. So we can see that in the numerator the 7's are going to eliminate each other, leaving 9x divided by 9. 9 over 9 is 1. 1 times x is x. And that's how inverse functions are supposed to behave. And so the first two we were given are not inverses of each other, but the one I created right here, those two are inverses of each other.